Okay, so I'm going to hide everyone. Now again, feel free to jump in and stop me if I get going too fast, because I'm going to kind of skip over some of this as it'll be repeating. And I just need to find out where oh, can everybody see my screen?
Yep.
And we're recording, so we're in good shape. Okay, so again, we're using the blank VI because it'll create programs that we can run without having to deal with the robot. Once we get into the robot, it's a little bit more cumbersome and we're more limited in what we can actually program. The main thing I'm trying to get to is a point where people understand while loops and case structures, because we'll be using those over and over. And again, feel free to stop me. I chuckled. I think Charles, who was familiar with LabVIEW, was kind of tickled because he had not seen the probes before. Well, an extension of the probes are going to be some of the things that we're going to do on the front panel, and I'll explain that as we get into it. The thing we're going to be identifying in tonight's session is the different colors that are associated with the different types of variables. For instance, a numeric value is orange, an integer is blue, the Boolean is green, and the string value is pink. And then the programming structures are the place we're going to be kind of covering a lot of new ground. So I'm assuming, unless anybody has an objection, we went about the right speed last time, so we're going to do that again. So this is pretty much a straightforward, just connect the dots, create a control of a particular, in this case, a numeric value, and then display it. And the point that probably the new line item is the fact that you can type in alphanumerics in the string control, and it'll display in the string indicator. So I'm not going to do that because we're going to run into it more so in some of these other examples. We've walked through the value or the benefits of using a while loop and the different elements. And did anybody play with the time element on the loop delay to see what was a good number to use for a human interface device? Part of the exercise was to try different constants. Anybody have any feedback on that?
I found that the 1000 did not do as much harm on the CPU.
Well, so how was the reaction time to your input to the control, though?
I couldn't see much of a difference. Like, if we're talking about how long it took for the joystick and the motor to connect. Is that what we're talking about?
Not just to connect, it's how it responds to your input. So what we're talking about is the human doing something and then the computer responding. So if you have 1,000 milliseconds, that's a 1 second delay, and it's usually pretty noticeable. And so the point to be made is you don't want to have something that slow, but you don't want to have it too fast either. So that's why you'll see me use numbers like 50 milliseconds and as slow as 70 milliseconds, and it will make a difference as we get into the robot. But I appreciate your input on that. Okay, so this I think is pretty straightforward. All we're showing is a numeric control, two different types of outputs for the numeric indicators. What I'm trying to show here, and this is going to be something I want you to construct on your own, is we can drive multiple loads. Anything that's on the receiving end of the signal is regarded as a load. So we can drive multiple loads with a single control, but you can't have two controls going into a single load. And that's like having two remote controls on your TV. You don't want to have dueling controllers. So you only have one input at a time, and it can feed multiple loads. So again, I'm going to have you do this, build this on your own. The point is just to make sure that 50 milliseconds works, and you can click the button and not notice a delay between the display. Okay, this one I want to draw, and I want you to see because I'm introducing what's called a case structure. And this allows us to do, you identify a case structure by the question mark on the left-hand middle side. What it allows us to do with a single Boolean control, we can control multiple outputs of different signals. So let's give this a shot, and feel free to follow along as I do this. So I need to. So again, we're going to start with a blank VI as soon as I get it up here. And I want to move this over to the side. So we're going to start with a blank VI. I'm going to set up two controls, a knob from the numeric palette and a Boolean push button. And then we're going to have two output meters. Now, to get a meters off the numeric palette, and once I put one down, I can hold control and drag it down with the arrow to a second copy. And then I'm going to right click and pick up another Boolean display. It's called a square LED, but if you put it on there, it's a rectangle. But if you position your little cursor correctly, you get the ability to expand the size of it. All right, anybody that wants to follow me, let me know if I'm going too fast. So I've got two controls, one Boolean, one numeric, two numeric outputs, and one Boolean. Now what we want to do is we want to, let me show you my equation, my word problem. When the Boolean is true, we want the meter to follow the knob and meter 2 to be half the value of the knob. And when Boolean is false, we want the meter to be 0 on meter 1 and 2, the number 10 on meter 2. It may sound confusing, but watch me as I do it. And the element that I want to use is called a case structure. So if I right click, go into my structure palette and select the case, and I'm going to build a left click and drag and build a rectangle about yay big. Now my Boolean control, you'll notice this is a green color question mark. That means we're going to control it with a Boolean signal. Now in the true case, if you'll notice, we have a little control pull down up here that shows false and true. In the true case, I want the knob to equal the meter 1, so the knob input, and the way this is done is I put a spool of wire on the nipple on the knob, and I left click inside the square, inside the rectangle, so it secures the tunnel, and then I want to drag it out to meter 1. Now on meter 2, I want it to be 1/2 the value. So what I'm going to do is multiply from the numeric palette that signal from the knob times, right click a constant, 2, multiply by 2. I'm sorry, multiply by 1/2. So I'm going to do 1/2. How about if I multiply by 0.5? And I want the output to go out to meter 2. Everybody follow that? So the knob comes in, goes across to meter 1, and then it comes down through a multiplication stage to meter 2, and the other input to the multiplication is 0.5. Then I want the Boolean control, the Boolean indicator. Now watch how I do this. I'm on the left-hand side where I see the nipple show up. I'm going to right-click and create a constant. It created a false constant for me. I'm going to position my cursor so that I pick this up. I put it inside, and it builds the tunnel for me. I deselect it, and then I position the white knuckle over it and click again to get the true value. Everybody see that? All right, so in the true case, I've got the meter straight through from the knob and multiplied by a half to go to meter 2. And then the Boolean input doesn't go anywhere, but the constant true goes to Boolean 2 output. Now for the false case, my meter 1 equals 0. So I'm going to notice I can pick up the pimple now inside the case structure, right click and create a constant for 0. And then my meter 2, I want it to equal 10. So right click, create a constant, and type in 10. Now the false case for the Boolean I want to be false. So right click on inside the case structure, right click and create a constant, and it is false. Okay, now what do I do? If I want this to be a repeating function, what do I do? Paige, what do you think?
Would you use a while loop?
Yeah, I would use a while. Exactly, a while. So I'm going to right click, position up in a white area, right click, go to structures, click on while, position the cursor in the top left, and then draw a big rectangle to contain it all. I'm going to right click down here on the loop control and create a control. And then I want to put my time delay out here in the while loop. So I pick up a wristwatch from the timing palette, right click, create a constant, and let's make it 55 milliseconds. So the word problem is based upon the condition of the true signal, connect the false when the Boolean signal is true, connect the false, the knob, to the meter 1, and then multiply by a half to get meter 2 and make the Boolean output true. In the false case of my Boolean input, make meter 1 0, meter 2 10, and my Boolean output false. So let's go to the front panel and see if it works. Okay, I'm in the false case right now for the Boolean. Meter 2 is 10 and meter 1 is 0. If I go to true, then meter 1 follows the knob and meter 2 is 1/2 the value of the knob. Did you get yours to work, Paige?
I'm a little behind, so not quite.
Okay, where'd you end up?
I didn't finish all of the true statement.
Okay,
so
you'll notice that when you go to false, if you haven't put an input on there, the white tunnel, the area for the tunnel will be white, which means you're missing an output. So go ahead and take your time and finish it. So under true, make sure you connect your knob from the input to the output to meter 1, and then bring down a multiplication. It's right click, numeric, multiply.
Sorry to interrupt you, but what Boolean do you use? Because I can't find it. The second one.
The second one down here? No, so,
Yeah,
all right, so did you get your display here, your Boolean indicator, and your Boolean control?
I have the Boolean control. I just didn't have the indicator.
Okay, right click, go to the Boolean palette, and pick out the square LED. And then click it. Then you can position your cursor so that you can change the size of the LED.
Got it.
All right. And when you go back to the block diagram, create the output on the Boolean indicator. Right click on it and say create a constant, and it will give you a false. Drag the F inside the case structure, and it will follow and create the tunnel for you. Did that work? Anybody else?
Yeah, I got it to work.
Okay, anybody else have a question about that?
Sir, for the block diagram,
Yeah.
where do you get the 0.5 and the little green box inside?
Okay, did you hear what I just explained to Paige about creating a constant on the Boolean indicator and dragging it to inside the case?
Yes, but I couldn't hear like where to find them because I have the knob and the Boolean and the X triangle in the middle, and I have the knob connected like in the middle down to the multiplication.
Okay, and you got it connected to the output for the top meter?
No, not yet.
Okay, so you need to put a meter indicator on the front panel. So you need 2 meters, and one of them, the top one, goes to the top output from the knob, and the second one goes to the multiply stage. Did you get it?
Yeah, I'm trying to connect them like right now.
Okay. We'll give you a couple seconds, no pressure. Something tells me Tate's trying to say something. Good. I'm a little slow on the update. Sorry about that, Tate. All right, so who was just talking? Is that
Me, my name is Leo.
okay, Leo? Did you get it sorted out?
Yes, I connected the meter 1 and the meter 2. Now I need to connect the Boolean in the bottom with that green box and the triangle with everything connected to the 0.5.
Okay, so on the Boolean, if you've got the indicator showing, you can right click on the nipple and drag that right click and create a constant. Right? You understand that?
Yes.
And you can drag that constant inside the case structure. And what it created for you has an F on it. And so you want the true case to be true. In other words, you want a T showing. And the way you change it is with the white knuckle.
Yeah, so at first when I did it, it showed me a T, and then I clicked the knuckle and it showed an F now.
Right. So you want a T under the true case, and under the false case, you want an F.
Right. So there. Oh, wait.
Okay, and the reason I want you guys to do this exercise again at home is to walk through these issues, because invariably there's some nuances in moving the mouse around and which button you click, and the more you do it, the better off you are. So, Lee, are you ready to go?
Apparently all that was in my false tab instead of the true tab.
Well, what are you going to do about it?
I have to
now look at this. Now, that's a pretty common mistake. If you right click on that control box, it gives you the ability to change the case just wham bam. So that's a good mistake to make now.
Okay, So yeah,
right.
I did that, and now everything is true.
Okay, I'm going to move on. Let's move on to the next one. Good inputs and good illustration of what I'm trying to do.
I have one last question about this, which is couldn't you also do the same thing with the light by connecting the Boolean input directly to the light?
Boolean to the what? The white?
Couldn't you also have the same effect as the constant inside the case structure
Yeah,
if you connected
exactly.
the Boolean input directly to the light?
Correct. And so that's not a bad thing to go. What I was trying to illustrate is the value. We could do the same thing with, in fact, that's a good question. And let's kind of move on to the next example. You can do the same thing with the select statement, the select icon in the comparison palette that we used the other night. Did we use it the other night? Everybody see the select where we select? So anyway, with two select statements, we can modify the direction that the knob signal takes, and we connect the Boolean output straight through to the Boolean indicator. So more to the point is, try it. Don't just take my word for it. Go ahead and try it on your own. And I'm going to move to the next example. All right, so I want you guys, when we send this out, I want you to rebuild what we just did. And then I also want you to make it up using the select symbol. Now this example, we actually already did. Thank you to, if it was Leo, I forget who told me to ask about the loops. But basically, we can set a stop or condition the stop of the while loop by comparing the loop counter against some constant value. And so the icon to use that is either equal to or greater than, and when you run it, it'll stop at whatever constant you put in there. So I'm not going to do that one now. Anybody have any questions about it? I'm thinking you can do it on your own. Now, I don't mean you to freak out, but now this is a big one. All right, it's called an up-down counter. So we're going to work on this together. We're introducing the concept of a shift register. So this little triangle looking thing on both ends is no longer a tunnel. It's been changed to a shift register. And what that allows us to do is that we start with the value 0, we modify it in the increment stage, and then we send it to this other tunnel at the end of the loop. And the next time the loop runs, we use that value as the input to the increment section. So here's how it works. Everybody ready for this? We're going to start a new blank icon, new blank program. And the first thing I want is a Boolean control. So let's make a Boolean push button. And then everything else I'm going to do from the block diagram. All right, so first thing I want to do is draw a while loop, a big while loop. All right. Next thing I want to put is an increment in there, which is a plus numeric function. Right click, go to numeric, the add function, put it right there in the center of my rectangle. Now right click on the top input. So there's 3 pimples. There's the input 1 and input 2 to the plus stage, and then the results of whatever that addition is. I'm going to the top one and right click and create a constant. I get the 0, so I'm going to pull the 0 outside and it's going to create the tunnel for me. Everybody there?
Sorry, can you do that again?
Yep. I'm going to do a Control Z and undo what I just did. I've got my rectangle. I'm going to right click numeric palette, add stage. Click it, place it, I'm ready to go. Hover over the top input until I get a spool of wire, right click and create a constant. The constant is 0. It's a numeric value. Notice it's orange. I'm going to use my little arrow and drag it outside of the while loop, and it's creating a tunnel for me. Everybody here? I'm going to hover over the loop tunnel, right click, and select Replace with Shift Register. And as I do that, it puts another little triangle on this side. So I'm going to take the output of the addition stage, of the addition icon, left click and drag with the spool of wire, and connect it to the other shift register. Everybody with me? Tate, you're doing a good job.
Could you do those last few steps one more time? Sorry.
Yep, not a problem. Okay, I'm going to move I've created a constant and I got the 0. I'm going to left click on the 0 and pull it outside. I'm going to hover over, I need to have an arrow, I don't want to have a spool. Hover over the loop tunnel, right click, and select Replace with a shift register. Click it, and it gives me a little up arrow over here. I'm going to use the spool of wire to left click and connect it to that triangle. You got it?
Yes, thank you.
Sure. Tate, are you hanging in there? Okay, now.
Can you hear me?
I can.
Yay! That's amazing.
Welcome to the party.
Yeah.
Okay, now watch this. This is pretty clever. Remember, with a select icon, we can change the value of the output with a Boolean signal. So I've got my Boolean signal. I want to put a select icon here underneath the add stage. Right click, go to the comparison palette, pick out the select. I'm going to do that again. Right click, comparison palette, left click on the select icon, select function, and place it right here under the, you don't want it to connect. If I place it too close, it connects to the addition stage. So you want to control that. Now, in fact, I do want the output to go to the plus stage, the bottom input. And I want my Boolean signal to go to the center connection of the select stage. So right now I have a Boolean input to the center connection of the select, and I have an orange data line coming out to the addition stage. Paige, you got it?
Yeah, I got it.
All right. Now watch this. We're going to increment by 1 when we have the Boolean signal. We want to just start and stop the increment stage. And so I'm going to right click on the top icon, input to the select, right click, create a constant, and make it a 1. So what I'm saying is when my Boolean is true, I want you to add a 1 every time the signal passes through the while loop. On the bottom input, so there's a top and a bottom and a center. The bottom input, I'm going to right click and create a constant and leave it 0. Okay, we're going to complete our while loop. I'm going to come down to the loop control and create right click and create a control. I'm going to right click, go to the timing, pick up the wristwatch. I'm going to put in constant. of 100 milliseconds. Now, I want to create an indicator to show what the count is, and I want to do 2 of them actually. So watch how I do this. Up here on the center of this orange line, I get a spool of wire. I can right-click and create an indicator. And this shows me the function that it's going to be indicating, which is going to be x plus y coming out of the addition stage. I also want to create one over here. So on the outside of my shift register, I'm going to right-click and create an indicator. And it's calling it X because it doesn't know what else to do with it. Date, have you got it?
Yes.
Okay. Anybody not there? We're going to make this thing run here in a second. Okay, go to the front panel. Use our little run arrow to turn it on. When the Boolean is false, nothing happens on our indicators. When the Boolean is true, our indicator on the inside of the while loop is clicking right along every 100 milliseconds. Everybody agree with me that's what's going on? So the lesson here is, why isn't the indicator on the outside of the loop showing us any numbers? You'll notice I can start and stop the counter with my Boolean input. And the reason is, when the Boolean is negative, 0, the loop is still going, but 0 is being added to that stage. Now watch what happens when I click stop. All of a sudden now my output on the outside of the loop equals the indicator on the inside of the loop. So there's a couple things here to know. One is the shift register takes the output from one execution and feeds it back to the next input for the next execution. The loop counter, in fact, why don't we come back here and do a loop counter? Just to prove a point. Come down to our little loop counter, right-click and create an indicator. So this is the number of times the loop is actually going to be executing. I come back here on my front panel. Here's my loop counter clicking right along. If I do a Boolean true, then my x plus y increment stage keeps up with it. If I click it false, it doesn't keep up with it. And then when I stop, it takes my x plus y value to the outside of the loop. Anybody not there? Anybody impressed?
I'm definitely impressed, and I think it's interesting that if you start it and stop it several times, that x value does not reset to 0. I expected that would be the case. Didn't.
Well, now see, because you're not starting and stopping the loop. If we were stopping the loop and restarting it, it would restart to 0. All we're doing is adding 1 or not adding 1 each time the loop is run. Good observation. And this is the way we're going to control a lot of movement on the robot. So this is called an increment stage. And if I were to say, okay, draw an increment stage, you should be able to pop this out in about 3 minutes. Just a word to the wise. What?
If you start and stop the actual program, it still doesn't reset to 0 because there's nothing.
Oh, the output doesn't reset to 0 outside the loop because there's no input to that. Is that what you were saying, Douglas?
Yeah.
And that's a good observation. Now, to that point, let's kind of talk some nuances here. Right now, we can tell that the program is running because the white arrow is dark, but we have access to this little red button, which is the abort. Now, when we're playing with the blank VI, like we're doing right now, we can stop this at any time and it won't hurt anybody's feelings. The better way to stop the execution is to use the stop button, because it, if you will, it closes it more cleanly and it doesn't leave anything hanging out there. Now, with that said, I can go back to my edit and reinitialize values to default to reset the value. Now, with that knowledge, there may be times when we need to consciously or reset the value on purpose and not count, especially if we're in a live program that's continuing, that and a good point, a case in point, if we're using a gyro compass to steer the robot and it's more accurate on short turns, then we're better off resetting that gyro right before we ever start a turn. And so, again, that's just one of the things you pick up when you're doing programming. But yeah, all good observations. So if you want to save this, it's called a counter. Save as counter. Now, I'm not going to close it. I'm going to build on it. Now, more of a common, I'll show you what we're going to do. We're going to do it now. If we wanted to make an up-down counter, instead of just counting up, we could put, what would we put down here in this bottom selection? Anybody want to hazard a guess?
Probably
-1.
Yeah.
Exactly.
Yeah.
Exactly. So try it. Let's put in a -1 and see where that leaves us. So go back to the front panel. So now when it's false, I'm getting down counting. When it's positive, I'm getting up counting. Very good. And again, this we will use in controlling, directing the camera on the robot. Okay, now just one more notice, and we'll get to the details on this when we do get to the robot. But what we will use this information for is to control a servo. A servo is a little it's a little motor that they use in RC controlled airplanes to control the ailerons and the rudder. And it doesn't rotate more than one revolution, but you can have control based upon the signal that you supply it. In the data sheet that they give us, there's a limit to how far you can drive it. And so you don't want it to exceed a certain value. So not tonight, but we will set up the limits on how far that value can change so we don't overdrive the servo. So that's just a little foreshadowing of things to come. Okay, I'm not going to do this one tonight. I want you guys to do it when we send out the homework. But basically, we're going to have 3 loops in series, and the difference being, we want to take the output from the control of the loop counter. It's going to run for 500 loops, and when it goes true, we want to send that signal to the next while loop. The point that I'm trying to make is the second while loop will not start until this signal is complete. And we do the same thing here. So they're daisy chained. And the point I'm trying to make is you can control the knob and see the slide move until this reaches 500, and then it stops, and then you have control in the second stage. So this is a 3-stage, if you will, control system, and I think you can manage it on your own. Anybody have any questions? You're welcome to try. Okay, so this is essentially a servo position controlled by a human analog signal. So what we're going to build here is we have a knob, that we're going to call launch position, range from 0 to 90 degrees. We're going to have a meter, which is going to represent the servo from 0 to 90 degrees. We're going to have a joystick button, which is going to fire, but we only want to let the launch mechanism fire when it's greater than 40 degrees. In other words, when the altitude or the attitude is too low, we could blow off part of our robot, and we don't want to do that. So the only time we allow the joystick button to fire is when it's greater than 40 degrees. Everybody get the premise on that one? Let's try it. So I'm going to get rid of this guy. Start a new blank VI. First thing I want is a knob for my numeric palette. I want to change the range from 0 to 10 to, I'm going to double click on the 10 and put in 90. I'm going to pick up a meter from the numeric palette. I'm going to do the same thing here. Make this 90. Now, if I wanted to be precise, I'm going to type this in as label it servo. And I'm going to call the knob, I'm going to double click on the knob and call it launch position. Misspelling doesn't count. We want to have a Boolean control, so I'm going to make it a push button. And we're going to call it, let's call it the joystick button for now. And I'm going to have another indicator that says enable. This is going to tell us when we have a signal greater than 40 degrees. And then I want another Boolean output. That's going to be my fire signal to launch the frisbee. Let's call it fire. And let's call this center one enable. Okay, so those are all my controls and my indicators on the block front panel. Everybody got them? Okay, I'm going to pull this over here so you can see it. Okay, I want my launch position up here to the left. I want my servo here to the center. My joystick button somewhere like that. Now, what I'm going to be using is my comparison values, and then what's called the Boolean logic unit. So first of all, we're going to start with a comparison greater than. Position it right here by the launch. Connect the output to the, and want to create the bottom input to be create a constant of 40. So we're looking for the value of something greater than 40 to be controlling this. We're going to want our launch position to control the servo. And we're going to call the output of this gate the enable. Everybody with me so far? Internet. Somebody, you lose the internet? It's been coming on and off all day, so I'm not surprised.
Yeah, but as long as you're recording, then we can still get it.
Yeah. Okay, so now we've got our enable, we've got our joystick. How do we control the fire button? We use a logic element that's called AND. So if I right click, go to the Boolean palette, pick up the AND function. I'm going to hook up one input to the enable, one input to my joystick button. And then the output goes to my fire control. This is again called a logic function, and its output is true only when both inputs are true. So it's called an AND function. And the way the logic equation or the word problem goes, when the launch position is greater than 40 and the joystick button is pushed, then we're able to fire the Frisbee. So now I put a while loop around everything. And give myself a control. Put in a timing element. And again, I'm going to make this 70 milliseconds because it's a human interface that I'm tracking. And I
Wait,
think
sir.
Yeah.
What kind of structure is it called again?
This outside structure
Yes.
is a while loop. So right click, structure, while loop. And you recognize it by the orange dot in the bottom right hand corner. Good question. Anybody else? Anybody have any questions about the logic control that we've set up? Let's see if it works. Go ahead.
Out of curiosity, why do you use such specific numbers for the timing?
I don't. I'm just winging it.
Oh, okay.
And I want you to do the same thing. There's some limits that you need to get used to, and you'll see it. They don't matter now, but it'll matter when we get into the robot. And so you'll see that there's different loops that we'll have in the robot control, and I like to stagger them so they don't all hit at the same time. And so you'll see me use 55 and 15, and there's no rhyme or reason. It's just I'm kind of winging it. Thank you for the question. Trying to put me on the spot, huh? Okay, we're ready to run. The run button. I can click my joystick button and nothing happens. I can unclick it, increase my angle to 50 degrees. I see my enable signal come on, and there I can fire. Anybody get it to work? Now this is called a gated signal. The signal that we're gating is the joystick control of the fire mechanism, and the gating function or the gating parameter is the launch position servo being greater than 40.
Now I noticed that your joystick button is pushed down and locked down, so that when your servo came up to 40, it automatically launched. Is it possible to have a momentary push switch rather than a click push switch?
It is. It turns out the actual physical joystick is a single pole, single throw. And the answer to your question is probably more than you want to know, but let's give it a shot. If I right click on the joystick button, it gives me the ability to show mechanical action. And so switch when pressed, switch when released, switch until released. And I think switch until release is what I'd probably try. So that gives me a more actual mechanism operation. Good question.
That's great.
Good question. You guys are thinking out there. I like this. Now, the reason I don't go into all that is because we're not going to be doing much on the front panel. But the answer to the question is yes. Just like most of the answers is going to be yes. Okay, any questions? Anybody not get it to work? Anybody have other questions? All right, so that's something else I'd like for you to be able to draw, and if you would practice it multiple times, because we will be using it again. Now I have two other functions here that I'm not going to go through. The main thing that these exercises are for are, one, have you practice the construction and work out the mechanism of connecting up multiple outputs. But you'll notice the first one is a 4-function calculator. I'll just hook one of these up and I'll show you what I'm talking about. The feature that I use, or we can use, to make it look a little neater is to start everything on the block diagram. So start over here, go ahead and put my while loop in, and then my function is going to be add, subtract, multiply, divide. You get the idea. I'm going to come back, put in my couple of controls. So I need a numeric input. If I want to repeat this, I click off of it, hold down Control, left click and drag with the little arrow showing, and it gives me the two numeric controls. And so now the deal is trying to figure out a clean way of hooking these up so it doesn't foul the mechanism. And then the thing I really want you to pay attention to is, once I've got this construction made, I can create, right-click on the output and create an indicator, and it labels the function that I'm indicating. So it's x plus y. And so over here in my output, I just arrange these in a nice order, and I don't have to make these up and relabel them. So I'm going to let you guys do the rest of that. I have both a 4-function calculator and a logic calculator. So there's an AND. So these symbols are consistent with any kind of digital design. This is the AND function. This is the OR function. This is the NAND function, not X and Y. And the NOR function, NOR, not X or Y. Play with them and see if they follow your logic. Okay, any questions? That was the homework that we sent out additional Monday or Tuesday. I want to send another set because it's going to be a long weekend, and I just want to kind of touch on these just because we got to get through them before we get to the simulator. And again, we'll go through these hopefully Tuesday night next week. Okay, this one's pretty straightforward. Basically, we're just looking, the output shows up when the loop is over. This one, we're using select stages controlled by a Boolean signal, and there's a daisy chain that will propagate to the output with different values. And so when everything is turned off, the output's going to be the input to the bottom of the daisy chain. When this output is turned on, and these control the motor, yeah. So see if you can, and this is the function we're trying to achieve. When the forward button is pressed, the speed indication is a -1. When the reverse button is clicked on, it's a +1. And when the launch is clicked on, it's 0 for motor speed. This is the one, I can't tell you how often I use this function. This is called the nested loop. And we'll spend a fair amount of time Tuesday talking about it. But again, it gives us the ability to do multiple functions on multiple signals, similar output as the select, but a lot more flexibility. So you may not be able to figure this one out before I explain it. This one I want you to give a try even before we get to it. This is called a flat sequence, and all we're doing is turning on, we're making a constant positive, a constant true input to turn the light on. There will be a delay for 1 second, 2 seconds, and then another second, and you'll see the progression of lights as the program runs. And where you get that is from the following. So the flat structure is under Structures, Flat Sequence. You draw a rectangle, and then you add a frame after. You pull it out.
Was that a right click you just did?
Yes. All right. So all we're doing is building three frames, putting a delay in each one, and then inside of a while loop. So that's one I want you to play on your own and see if you can sort it out. This is the same thing, but it uses local variables, so I'll have to explain that. No, let me do it right now. So it turns out what we're doing down here at the bottom is we have 3 indicators, these 3 indicators here. And if I create an indicator on the front panel, and I hold down Control, use my little arrow, 1, 2, then these are outputs that can be used, and what I want to do is connect the inputs to them. And so the technique is right-click on the indicator and create a local variable. And as I do that, it gives me this little box that I can put up here. And once I've done that, it gives me all 3 variables. So I'm going to put 3 in each one. What we want to show is a ripple counter on our output. Now watch, once I've done this, I can select all 3 and then Control, drag and drop. Now this will be 2 and this will be 3. Should have done that before Then all I have to do to assign a value to each one in each section is say, okay, create a constant. And frankly, this is something I should have done before I copied and drag and dropped. I want the light to be on for the first second and put a delay here of 1,000 milliseconds. And I'm going to turn it off in this frame. and turn on the second one. You guys get the idea?
How did you get the multiple boxes in the flat sequence?
Just a second. You have to create them one at a time. You're talking about the sequence itself?
Like, I have the flat sequence, but it's only one box, and you have three boxes. How do you...
Right-click on the right-hand side and add a frame after. And then drag it out however big you want it.
All right.
Then you put this in a while loop. And so the idea is, as this thing progresses, you'll see one light go on, and then the next light go on, and then the next light over the course of 5 or 6 seconds. Okay, let me see if there's other ones you can work on with minimal guidance. This is the same thing, it's just more complex. There's nothing new other than I put a while loop by itself, have 2 while loops running simultaneously. You may want to give that a try. Again, there's a lot you can learn from making mistakes. Here's my increment counter. Nothing really new there. Here's the up-down counter. Again, we're using a case structure. You notice the first time we did this, we used a select. This one, I'm using the case structure. I'd like for you to play with that one. And here's the one with limits. And so this one you can hold off on just because I need to explain nested loops for you, but this is how you protect physical damage on the robot. Okay. So I'm going to send copies of both of these to you, and I'll have a link to the video. Any other questions?
Can you also give us a link to the video from the first night's class?
I don't think I recorded. I have to look.
Yeah, you did.
Okay. I'm not sure I kept it after I recorded it. At any rate, I'll send you a copy of this one. If I can find the other one, I'll send that along as well. Everybody get, anybody didn't get homework assignments, make sure I get your email address so your coach knows you need to get it from him. Any other questions?
With the homework assignments, are we supposed to turn them in somehow?
You know, if you can send back, you can attach to an email the blank.vi that's located in LabVIEW data. In other words, if you go look at what we've been building up, when you save it, it is located under My Documents, LabVIEW data. And so here's what I've saved as far as blank VIs. Ones I've been doing tonight I haven't saved, but it'll be, so if you have a question or you're having a real problem, I would encourage you to send it to me. If you have it under control, you don't need to. We can just talk about it. But frankly, I can tell a lot by how much you're getting if you just send me a copy of a couple examples that you got right. Any other questions?
Jim, I have a question.
Yeah.
This may be too advanced for right now, but since we always seem to want to have a timer in our for loop or while loop, can we create like some kind of custom object in a palette that's a loop that already comes with a timer?
The answer is they've done it. So the answer is yes, but I wouldn't recommend it. And we'll kind of go through those choices. But if you go in and look at the Express, we haven't talked about the Express. Let me see. The Express palettes, with express functions are created by students, and sometimes they don't work the way you want them to work. So I guess I wouldn't, bottom line is I wouldn't recommend it. You'll find that what you think works right every time doesn't necessarily work right every time. And you're better off making sure you have control of the time, because it is going to be a key element in every program you do. So
Okay.
I'm glad of the question, though, now that I thought through it. Anybody else? So what we're going to do next week, and you really need to do these exercises because we're going to be deep up to our elbows in robot code, and we're going to be using the simulator. And who was it that was asking me about a joystick last week? Somebody was insistent that we could work without a joystick. Never mind. The first thing we're going to do is how to simulate the joystick in the driver's station so we can navigate a maze with better precision than you can with the joystick itself. So stay tuned. That's all I got for tonight. Anybody else, feel free to email me. Have a good weekend, and we'll talk to you next Tuesday night.
Thanks a lot, Jim. Appreciate it.
So long.
Thank you.
Thank you.
Bye.
Thank you.
You're welcome.